The Physics of Gymnastics, Genius Hour Project 2016. The main reason I wanted to research this project is because I wanted to understand more about how the sport of gymnastics actually works. I've been doing the sport since I was 2 years old, but I've never really understood how we're able to do big skills. If gymnasts and coaches can better understand the physics behind what they're doing, it will help advance their knowledge during their training. In addition to more knowledge, this research can also help improve the safety of all who wish to be involved in the sport. With gymnastics being such a demanding activity on the body, it is important for the athletes to stay safe while also enjoying their time in the gym. Centripetal force is a center-seeking force. The centripetal force equation, derived for the case of circular motion, is mass times velocity squared divided by the radius. The units for the centripetal force equation is kilograms for mass, meters per second for velocity, and meters for radius. As you can see in the diagram below, the centripetal force causes the object to move in a circular motion unless something happens, like in this situation, the string breaking, causing the mass to follow the straight line path in the direction it was traveling at the time of the break. This relates to gymnastics during a skill called giants around the bar. This circle represents the circular motion that I am traveling in. The radius is my height, which is 1.87 meters, my mass is 49.9 kilograms, and using the basic velocity equation, I found my velocity to be 5.99 meters per second. The circumference of the circle is 11.75 meters, so I multiplied that by the amount of times I went around the bar and divided it by the total time it took me to do my 5 giants. Now that we have all our variables, we can plug them in to figure out what my centripetal force is as I go around the bar doing giants. Multiplying my mass, 49.9 kilograms, times my velocity, 5.99 meters per second squared, and dividing by 1.87 meters gives us 957.44. The centripetal force as I swing around the bar is 957.44 newtons. The next physics concept that I chose to explore for my research was projectile motion. As you may recall from earlier in the year, a projectile is an object only under the influence of the force of gravity. Projectiles always have a parabolic trajectory, which just means that their motion represents the shape of a parabola. Projectiles have horizontal motion, Vx, vertical motion, Vy, and resultant motion, Vi. The picture below shows the different types of projectiles, including freefall, objects going straight up and down, and objects traveling further distances. Gymnasts represent parabolas when they perform tumbling passes and skills like double backs, which can be seen in the upcoming video. In this diagram, I have labeled Vx, Vy, and Vi, as well as theta, the angle at which I set to take off to do my skill. The first dot is where I punch the floor to start, the second dot represents my max height, and the third dot represents where I land. The total distance that I travel doing my double back is 2.41 meters, and it takes me 1.17 seconds to complete the skill. Using the equations for projectile motion as well as trigonometry, we can figure out Vx, Vy, Vi, and theta. For Vx, change in position over change in time is 2.41 meters divided by 1.17 seconds, which gives us a velocity of 2.06 meters per second. For the Vy equation, 9.8 meters per second squared is acceleration due to gravity, and 0.59 seconds represents half the time of the total skill, which is the time to the peak. This equation results in a velocity of 5.78 meters per second. To find Vi, we just use the Pythagorean theorem, so Vx squared plus Vy squared equals Vi squared. Using this equation, we end up with an initial velocity of 6.26 meters per second as I do my double back. The last step to find theta is to find the tangent, which is Vy over Vx, and take the inverse of that, which results in a theta equaling 70.38 degrees. The final physics concept I chose to explore for my research was center of gravity. Center of gravity is defined as the theoretical point at which all of the body's weight is considered to be concentrated. Basically, all of the forces on the body are summed at this point. The location of the center of gravity may change when someone's position changes. The picture at the bottom shows that we are only stable if, when a vertical line is drawn from our center of gravity, it reaches the ground within our base of support. So, with this block, it is stable at points A and B, but not at point C because the vertical line is now outside the base of support. The center of gravity in females is approximately 55% of their body height, and the center of gravity in males is approximately 57% of their body height. Therefore, my center of gravity is right around my waist. In these pictures, my center of gravity is represented by the red circles. While I am doing this skill, called a back handspring layout step out, I must keep my center of gravity in line with the 4-inch beam. The bottom graphic illustrates that when we lean over and get out of our area of our center of gravity, we fall over. It is so difficult to stay on the beam because a gymnast must keep their center of gravity in a 4-inch wide space. As soon as we begin to accidentally lean to one side or jump slightly crooked, we fall off of the beam or receive a large deduction because of wobbling in an attempt to rediscover our center of gravity. All of these physics concepts can help gymnasts and coaches have more knowledge when training. I hope this research helps them train in the best possible way to remain safe and healthy while doing the sport they love.